The trebuchet was a war machine which was invented in China in 300 BC. It was used in the medieval ages to throw heavy projectiles with great accuracy. The trebuchet was important because it represented one of the first machines that utilized gravitational energy. Gravity is a force created by the mass of the object. Gravitational energy is used in many modern machines today, most notably by generating kinetic or motion energy and converting it into electric energy. For example, water machines are spun using the weight of water to spin the wheel and generate electricity.
How does a trebuchet work? The concept for a traditional trebuchet is fairly simple. It includes a long arm, a short arm, and a counterweight, all operated by a pivot. A projectile is attached to one side of the long arm, the sling, and the counterweight is raised. When the long arm is released, the counterweight drops, and the projectile is flung into the air. The energy stored in the counterweight is transferred into the projectile in the form of kinetic energy.
Now let's talk about the physics of the trebuchet. As the beam of the trebuchet rotates, the projectile experiences linear acceleration, which is defined as the rate of change in velocity per unit of time. This causes the projectile to move outward. This results in a large increase of linear velocity of the projectile, which far exceeds the end of the beam where the sling is attached. This is the concept of mechanical advantage and is why the trebuchet is able to attain such high speeds.
When a traditional trebuchet is released, the counterweight falls vertically and almost comes to a complete stop before being pulled horizontally by the arm. This means that the potential energy of the counterweight is transferred to the projectile as well as the arm. For the most efficiency, the counterweight and arm must not be moving at the point where the projectile is released. Because of this problem, we decided to go for a slightly different trebuchet design. This new trebuchet design is called the Whipper Trebuchet. The Whipper Trebuchet has a much shorter arm than a traditional trebuchet, which allows the Whipper Trebuchet to rotate 360 degrees. The counterweight is attached in a similar way to a traditional trebuchet, but the biggest difference is the launch position. The arm which the projectile is attached to is rotated almost 180 degrees. This raises the counterweight above the main axle, which then increases the amount of gravitational energy.
Here's what we came up with.
Alright, here's the trebuchet that we have built. Down here you have our counterweight arm, which is attached by a pivot which is connected to our main axle, which has our arm up here with our sling and our firing mechanism at the very tip. So now we're going to show a clip of this trebuchet firing. Fire in 3, 2, 1.
Sensors are defined as devices which detect or measure a physical property and record or respond to it. Sensors are used everywhere in everyday life. Sensors can be utilized to optimize a trebuchet by measuring the speed at which the projectile is launched. This could also be used to measure the force at which the projectile is released, and the information can help us by improving our trebuchet. We hope to utilize sensors to improve our trebuchet in the future.
In conclusion, the trebuchet was a very important part of the medieval history and a very important history of technology as well. The trebuchet uses levers and potential energy to operate. Levers are very important because they allow people to do work using less initial force. We see levers all the time in our day-to-day life on a day-to-day basis. For example, from scissors to wheelbarrows.
We're Team 1715T, and thank you for watching our STEM.